Hello and welcome to another video on linear equation, the use of integrating factor. Right? I'm giving this question. How do I know I'm using integrating factor? We said that integrating factor generally must be of this nature: dy over dx plus p multiplied by y equals to q, where p and q are function of x. Now, I'm giving this question. Doing comparison, it is a linear equation, so I have to use integrating factor. And also recall, the formula for integrating factor is equals to exponential integral of p, right? Now, from here, let me identify my p and q. P in this case is 3. The function of p in this case is 3. And the function of q in this case is sine x. The next thing to do is to evaluate integrating factor from the given question. How do I get integrating factor from this given question? It means that for this question, integrating factor is equals to exponential integral of 3. Solving for integral of 3, that's 3x, right? Don't forget, don't introduce your constant when you are doing your integrating factor. Okay? Meaning, for this question, integrating factor is equals to exponential 3x. Right? From here, next up, what you should do is to multiply the integrating factor by the original equation, by the left hand side of the original equation and the right hand side of the original equation. Multiplying the left hand side of the equation by the integrating factor, integral 3x open bracket dy over dx plus 3y equals to, multiplying the right hand side by integrating factor, equals to exponential 3x sine x. Open your bracket, exponential 3x dy over dx plus 3 exponential 3x y equals to exponential 3x sine x. From here, when I'm giving a differential equation, my interest is to get the function being differentiated, right? This left hand side, this is the left hand side, and this is the right hand side. I can write the left hand side as the derivative of y times integrating factor, which is 3 exponential 3x equals to exponential 3x sine x. The question is why. Why am I writing the left hand side as the derivative of y times the integrating factor? What it means is that generally, when you know your integrating factor from the given question, what will be in the left hand side? It is the derivative of y multiplied by the integrating factor with respect to x equals to the integrating factor multiplied by the function on the right hand side. Let's prove this. Why is it so? Let's solve the derivative of this using product rule. From here, this is u, this is v. U is taking v as constant, that's y, multiplied by the derivative of this 3 exponential 3x plus taking exponential 3x as constant, exponential 3x multiplied by the derivative of y. How do you get the u dx in this case? If u is a function of y, to get the u dx, your implicit differentiation, differentiate both sides with respect to x. The u over the x is equals to dy over the x. So therefore, we are multiplying exponential 3x by dy over the x. So from here, what can you say about this and what we have here in the left hand side? You can see that it is the same, right? Okay, let me rearrange it in that same format. Exponential 3x dy over dx plus 3 exponential 3xy. What we are saying is that once you know your integrating factor in a linear equation, what will be the left hand side of the equation is the derivative of y and the integrating factor with respect to x, equating it to the integrating factor times the function that's there, which is sine x. So that's it. That's how it works. From here, applying what you know about separable variable, the x should come here. We have d open bracket y dot exponential 3x equals to exponential 3x sine x dx. Integrate both sides. Integral d open bracket y dot exponential 3x equals to integral of exponential 3x sine x dx. Now, integral cancel this derivative, meaning y exponential 3x is equals to integral of exponential 3x dot sine x dx. Now, the question is, how do I integrate the right hand side? Integrating the right hand side using product of integration, meaning by parts. That's the only possible way we can do that. We are having product of integration, so we are using integration by parts. Now, meaning we are relating the product of differentiation to integration. And what we know in differentiation is that given the function uv, the formula is what? U dv over dx plus v du over dx. Now, add, this is differentiation, product of differentiation. We are relating product of differentiation to product of integration. Then add integral to this place, add integral here. Then make the middle one, which is integral u dv dx, the subject of the formula, meaning integral u dv over dx is equals to uv minus integral v du over ds. What it means is that in differentiation, product true, we'll be given two functions uv. In integration, we are given two functions as well, but the two functions is u and dv dx, meaning the function of v has been differentiated with respect to x. That's it. Now, relating that idea here, which one is my u, which one is my dv dx? This is my u and this is my dv over dx. Why am I saying this is my u? Why is this dv dx? This is how it works. When I'm having integral of two functions, the function in this case is exponential and trig function. Now, priority is given to the exponential, meaning that when we say priority is given to the exponential, it means that u will be the exponential involved. U is what? Exponential 3x, and the v dx will be sine x. So that's how it works. What if we have the two functions in this case involved in this integral is ln x and exponential 3x? Priority will be given to ln x, meaning u will be what? Ln x, while the v dx will be exponential 3x. But you can watch my video under by part for more understanding on integration by part. Okay, from here we already know that this is my u and this is my dv dx. Using this formula, I need u. U is what? Exponential 3x. What's v? V is unknown. From here, v is unknown. What's du dx? Du over dx is unknown. But I'm giving the v dx. I'm giving the v dx to be sine x, meaning I can get v. By the time I integrate the v dx, I can get v. By the time I differentiate u, I can get the u dx. That's the meaning. Okay, from here, integrating sine x, that's what, when I integrate sine x, the integral of sine x is minus cos x. S it means that the u over the x is what? Cos x. What about v? Sorry, integrating sine x, that's cos x. Hence, it means v is what? Cos x. Why? Because to get v, we integrated sine x. It works. Integration is the opposite of differentiation. We are given a function that was integrated, which is dv dx. Then how do I get v? It means I have to integrate. The function in this case, which is dv dx, is sine x. Then to get v, integrate sine x. That will give us cos x. Meaning cos x is equals to v. What about du dx? How do I get du dx? I can get du dx by differentiating u. If u is equal to exponential 3x, if u is equals to exponential 3x, it means that the u over the x is equals to 3 exponential 3x. Then you can substitute the value of u to be this. Substitute the value of v, which is cos x, minus integral, substitute the value of v, then du dx, 3 exponential 3x. You can see how it works from differential equation to integration. So you have to be a master of your integration. Okay, let's solve this. Substitute your respective value into this. Integral u dv over dx is equals to, what's my u? My u is given, that's exponential 3x dot, what's my v? I integrated the v dx to get v, that's cos x, minus integral, what's v? Cos x, dot du dx, 3 exponential 3x, 3 exponential 3x. Okay, from here, it means that the integral of the right hand side, which is this, is equals to exponential 3x minus cos x minus integral of cos x dot 3 exponential 3x. 3 is constant, so we can bring 3 out. Let's bring out 3. You have minus 3 cos x dot exponential 3x. From here, I'm still having integral form in the integration of the right hand side. What it means is that I'll still have to perform integration by part. I'll still do integration by part to eliminate this integral function. So applying integration by part to this, it means we have, this is my u and this is my dv over dx. This is my dv over dx. Using this formula, from here, the u over dx, if this is u, then the u over dx is what? 3 exponential 3x. Then v, by the time you integrate cos x, what do you have? By the time you integrate cos x, we are having sine x. Sine x. Substituting the respective value into the formula of integration by parts, we have du, okay, we have u, which is exponential 3x dot v sine x minus integral, what's v? Sine x dot du dx is what? 3 exponential 3x. Just calm down. I know it might be confusing. Just calm down. It is very easy. You know, in differential equation, this is the relationship we got. We are solving, we want to know the function of y, a function that was differentiated. And up to this level, this is the left hand side, this is the right hand side. By the time you integrate the right hand side, this is taking us back to integration. How do we integrate the right hand side? We are now using by parts of integration. Normally, I should just write out the answer. But how do we get that answer? That's what we are showing here. And the first thing we did was we implemented the formula of by parts, and this is the formula. Then from this formula, I need u, I need v, I need integral of v du dx. From here, I already know u, I already know the v dx. This is u, this is the v dx. Then how do I get v and the u dx? Since we know u to be this, the u dx, just derive it, just differentiate. And that's how we got 3 exponential 3x. Since we know that the v dx is sine x, how do I get v? Integrate, that will give us cos x. This approach is just your understanding on differentiation and integration. So you can brush up your differentiation and integration. So that's it. From here, substituting the respective value into this formula of by parts, we then have that exponential 3x multiplied by cos x minus integral of cos x dot 3 exponential 3x. Meaning I've gotten the integral of the right hand side. But observe, you are still having integral form in the expression. Meaning you are to eliminate this integral form. And by the time you look at it, how do we eliminate it? It's still the same by parts you are still going to do. Are you with me? Now, applying by parts here, it means this is my u, we know why it is u, this is my dv dx, we know why it is dv dx. Then, using this same formula to get your v and to get your du dx. From here, if this is u, this is du dx, this is the derivative. If this is dv dx, this is the integral sine x. And by the time you substitute the respective value, this is what you got. So that's how it works. Now, let's bring everything together. Let's bring everything together. It means that the integral of the right hand side, which is exponential 3x dot sine x dx, is equals to exponential 3x. When we did by parts first, this is what we got: exponential 3x dot cos x minus integral of cos x dot 3 exponential, and we say 3 is constant, so we are bringing out 3 here. 3 integral cos x dot exponential 3x. Right? Now, doing by parts to this integral form, we are also going with by parts to this integral form. And when we did that, this was the expression, this was the answer. So we can just bring this answer. Let me call this 1. We can bring equation 1 into this place. Substitute equation 1 here. Then it means that we have open bracket, we are substituting equation 1 to be this integral form. Open bracket, exponential 3x sine x minus integral. Okay, 3 is also constant here. Let's bring out our 3. 3 open bracket integral sine x dot exponential 3x. So when we integrated the right hand side, this is our answer. So from here, what can we say about this? Observe, the right hand side that was integrated is still in the answer we got, is still in the expression. Meaning you can do an absorption. Meaning you can do an absorption that let I equals to integral of exponential 3x sine x dx. There is dx here. Exponential 3x sine x dx. Meaning anywhere you see this expression, then what will be there? I. Right? So we are saying that I is equals to exponential 3x dot cos x minus 3 open bracket exponential 3x sin x minus 3i, right? By the time you multiply 3 times this is I, will give us 3i, which is equals to I equals to exponential 3x dot cos x minus, open your bracket, minus 3 exponential 3x sin x plus 3 times this will give us what? 9i plus 9i. So what you are saying is that the right hand side that you want to know the integration that you are integrating, you represented it as what? I. Anything you get for I, that's what you are bringing here. That's the meaning. Okay? From here, collect like term, right? By the time you collect like term, it means that I, this 9i will come here, minus 9i equals to, this one still remain here, equals to exponential 3x cos x, right, minus 3 exponential 3x sin x. What's the LCM? Oh, sorry. From here, this minus this is what? Minus 8i, right? Equals to exponential 3x cos x minus 3 exponential 3x sin x. Then divide both sides by minus 8. It means that I, which is equals to the integration of the right hand side, I, which is equals to integral of exponential 3x sin x dx is equals to exponential 3x cos x minus 3 exponential 3x sin x over minus 8, right? So that's it. You've integrated the right hand side. Then from here, back to what we are doing. It means y exponential 3x is equals to, bring the whole of this there, is equals to exponential 3x cos x minus 3 exponential 3x sin x divided by minus 8. It means that the integral of the right hand side, which is exponential 3x dot sin x dx, is what? This expression. So that's how it works. We are doing integration in differential equation. So you have to be solid in your integration. So from here, to get y, multiply both sides by the reciprocal of exponential 3x, or you say divide all through by exponential 3x. So meaning y exponential 3x all into brackets 3x all into brackets 1 over exponential 3x equals to exponential 3x cos x minus 3 exponential 3x sin x divided by minus 8 multiplied by 1 over exponential 3x. Then this cancel this. It means that y is equals to exponential 3x cos x minus 3 exponential 3x sin x divided by minus 8 multiplied by 1 over exponential 3x. So this is the value that was differentiated. But let's simplify further. From here, y equals to 1 over exponential 3x. This fraction is still the same thing as exponential 3x cos x divided by minus 8 minus 3 exponential 3x sine x divided by minus 8, right? Then multiply by 1 over exponential 3x. Then open up the bracket. Exponential, okay, let me show it. It means exponential 3x cos x divided by minus 8 times 1 over exponential 3x, right? Minus open bracket 3 exponential 3x sine x divided by minus 8 open bracket 1 over exponential 3x. Then this cancel this, right? This cancel this. That's y is equals to cos x divided by minus 8 minus open bracket 3 sine x divided by minus 8. Then from here, it's still the same thing as cos x over minus 8 plus 3 sine x divided by 8. Rearranging y. This is your final answer, but you can rearrange y, bringing the positive term first, meaning y equals to 3 sine x divided by 8 minus cos x over 8, which is equals to 3 sine x minus cos x over 8. So, meaning from the differential equation, this was the function of y that was differentiated. So that's it. That's how it works. If you find the video interesting, do well to like, subscribe, comment, and share. So this comes to the end of linear equation, the use of integrating factor. Don't forget, the steps remain the same for every question. It just depends on your ability on how to tackle your integration. And your right hand side, you always have your right hand side. Once you've gotten your integrating factor, the derivative of integrating factor multiplied by y with respect to x will always be at the left hand side of the equation, equating that to the integrating factor times the function in the given equation. So that's it. See you in the next video.